LA Softstory Ordinance was passed just recently in the last 1 year in the city of Los Angeles, affecting over 15,000 buildings in the city of LA. And the purpose of this educational video is to give you an overview of that ordinance and to talk about how it impacts thousands and thousands of people in Southern California. The ordinance was passed approximately 8 months ago. It affects over 15,000 buildings. And I want to first explain to you what the meaning of soft story is. So you can see from the video what happens in a soft story condition. The building with the soft story condition was a total collapse and it actually rolled over. The building that was retrofitted survived. The cities that have critical seismic zones, which includes Los Angeles, San Francisco, Oakland, Sacramento, recognized this as a risk and collaborated together to develop the soft story ordinance. And so they have embarked on creating a seismic rating system and an ordinance requiring building owners that have this potential risk of collapse to retrofit their buildings. It's a safety measure. The City of LA created the safety measure, and it's called the LA Seismic Retrofit Program, Los Angeles Seismic Retrofit Program. And this handout, which is available, you'll see the link up on the screen, gives you the basic parameters and also tells the tenants in buildings like this. With over 15,000 buildings affected, it's a fairly drastic ordinance. The timeline for implementing the ordinance is approximately 7 years. Let's go over the timeline. So the building owner has, from the date of the order to comply, which is when they get the notice, they have 7 years to comply with the ordinance. In the first 2 years, they have to submit proof that they have hired an engineer and that they're in the process of retrofitting their building. And the city's quite serious about this. The city will issue the order to comply, and building owners that don't comply will be subject to penalties. So it's a mandatory ordinance, and the tenants will be made aware. Order to comply will be issued, and it will affect the title of the property. So as a building owner, you've got to comply. The first thing we want to do is we want to identify all the buildings that are at the greatest risk. So this step number 1 is being done by the City of LA. The City of LA is doing that. I don't need to go into that with you. They are the ones that are going around and identifying those buildings and then issuing orders to comply. When the owner gets the order, the owner then has to mitigate those risks by strengthening the buildings. The city is also trying to provide some financial incentives to those building owners so that they can help to finance this or create tax benefits. That again is a separate topic. It's outside the scope of this presentation, but there are some financial incentives out there. We're going to focus on this topic, how to mitigate. What do we do? How do we strengthen the building? So here's a great sketch which I took courtesy of the Los Angeles Times, which kind of explains very nicely in 3 dimensions what the danger is of a soft story. So here on the left hand, you can see the building which has a pretty robust second story with these weak columns. This is very, very common in Hollywood, Santa Monica. I'm sure many of you are living in these buildings. When you see this type of a framework, that is potentially a soft story and a collapse hazard. In a fairly moderate earthquake, that entire building will collapse. And you can see that illustrated in the second portion of the figure, which shows that under lateral movement, that entire floor will collapse, that entire floor will come down. And obviously, if you have 2 or 3 or more stories up there, and we are, being Los Angeles, being very densely populated, the risk is even higher. So what do? Well, the solution focuses on using strengthened columns, either steel columns, moment frames, or possibly shear walls, to strengthen that lower floor so that it does not have a weak stiffness line, so that it doesn't collapse. So what we're doing is we're taking these existing columns and we're either replacing them or we are upgrading them. So I drew this sketch for you before. We have to strengthen the weak column line. And so what we're going to do is we're going to come in with our solutions. Here are the options. One option is retrofit options. We can add new shear walls. I'll explain what that is. A shear wall is essentially a wall that comes in to supplement the stiffness on the ground floor. And you have your upper floors up here, and that creates a higher stiffness. It's basically strengthening using a wall. Another idea is to use a steel moment frame, and we'll talk about a steel moment frame in a second. We can also add new steel columns, which we call flagpole or cantilevered column. I'll go into that in a minute. We can also strengthen the existing columns. If it's already steel, maybe we don't need to replace the existing steel. Maybe we can strengthen it. Maybe we can box it up and create a tube. I'll explain that also. We can strengthen the existing framing with shear walls and or strong walls. We'll talk about that. So here you have 5 options, and it depends upon your structure. It depends upon what the logistics are. It depends on how many floors there are. The first step is to examine the structure, do a feasibility study, and try to see which one of these is the most cost effective. For example, let's say we're looking at, here's an example, hypothetical example, 1, 2, 3, 4 stories over my soft story. In this example, two solutions. One is to put in 2 shear walls, and the other one is to put in a single moment frame. Now, what's the problem with the first one? The first one is most likely going to be cheaper. But the problem is, as you can see, is you lose parking. And that's the problem with shear walls. They take up the parking, and no tenant likes to lose their parking. Second option is a good option, but I want to go into the details of putting a moment frame in. It's a lot more involved than just what this drawing shows. Steel moment frame is a combination of columns and horizontal beams that are rigidly connected at the joints. What do we mean by rigidly connected? And let me try to explain that with a simple sketch. If I have a frame which is made of steel, and I apply a load on the side, if these are rigid connections, which they are supposed to be, and everything here is made out of steel, when this deflects, it's going to deflect like this. It's going to deflect in a way that the angle between the column, here's my beam, that angle between the beam and the column always remains at 90 degrees. In other words, there is no rotation. The fact that there is no rotation means that there's a very high bending stress that's occurring on those beam column joints. As opposed to a hinged connection, if we allow rotation, then what happens? The frame would deflect like this. Then it's no longer a frame. Well, it's still a frame, but it's a pinned. If it's pinned, then it will deflect like this because this is allowed to rotate. What's the difference between the two? This one, which is a steel moment frame, will have a shorter deflection. It's much more stiffer. This one, which does not have a moment frame, this is a cantilevered column, will have a higher deflection. So it all depends on whether or not the building can tolerate the higher deflections. What's the difference between the two? The steel moment frame requires a grade beam that has to be dug inside. There's a whole concrete beam that has to go in there. And this connection is a very, very detailed connection. It requires welding, it requires bolting. It's more expensive, but it's the best solution, I will say that. From an engineering standpoint, you can't beat a steel moment frame, but it is also more expensive. The cantilevered column, which is the one shown on the bottom, can be designed with a footing. It's a cheaper solution, in my opinion, easier to install, but it has less stiffness. Now, the question is, in terms of stiffness, you have to look at what do you need. Do you need, if it's only a 1-story, we may not need a steel moment frame. Maybe we can do a cantilevered column. The cantilevered column, what I like to use is what's called a structural tube. And a structural tube, exactly what it says it is a steel tube which is then connected down at the base with a steel plate with bolts that then go into a concrete foundation. Why do I like this solution? Because the structural tube can take loads in both directions. It has symmetry. It has symmetry, so when I do a design, and let's say I recommend an 8-inch by 8-inch by half-inch thick structural tube, I like that solution because I get strength in two directions. As opposed to doing an I-beam, a lot of people, they use the I-beam. The I-beam is strong about one axis and weak about the other axis. It's very strong in my little sketch here. It's very strong about one axis, the x-axis, but it's very weak about the y-axis. It does not give you the same strength in both directions. So there are multiple options, and the same thing applies when we go to looking at these other choices. So let's look at the wood shear wall. A wood shear wall is essentially a system of studs with a top plate and a bottom plate with plywood sheathing. And what does a wood shear wall do? When you put the plywood sheathing and you apply this force, this plywood sheathing, which sandwiches to the stud, prevents the shear wall from deflecting. It's as simple as that. If you didn't have the sheathing and you just had the studs, the wall is less stable. You apply the load, the studs will just bend. But when you put the sheathing on, it ties it all together, creates a panel. And that's what a shear wall is. What about the fourth option, strengthening existing columns? What do I mean by that? Let's talk about that for a minute. So let's say your building has some steel columns already in place. Usually those columns will be in the form of I-beams. They'll look like this. So maybe when we look at your building, we find that the steel columns are already there, but they're not big enough. Well, we can come in and we can weld new plates on the side of that steel column. We can also weld new plate on the stronger side, and we can box that in and create a new column, which is much stronger than the original column. So it's more than one option, and maybe the strengthening of the existing column works. Again, there's no one solution, there's multiple solutions. They apply to different cases, and the job of the engineer is to give you those choices and help you decide as an owner which one you can afford. The other option on the list is the strong wall. So we can also use adding a strong wall. What is a strong wall? So a strong wall is essentially a shear wall, but it's a proprietary shear wall developed by a specific manufacturer, which has a super high strength and it's not as long. In other words, this distance here can be as short as 2 feet. It can be as short as 18 inches. I think they even go down to 12 inches. So what does that mean? It means that if you have 12 inches to work with, you could possibly put in a strong wall. But as you saw with some of the slides that we looked at, 12 inches may sound like a lot. It's about a foot. You may not have a foot. In some cases, some of these columns are only 6 inches wide. If I put in a 1-foot strong wall, what have I done to my parking? I've lost my parking. And again, parking is a sensitive matter. So strong walls can be used in certain instances where if you have the length and you can do it, then by all means it should be considered. But if you don't, then you have to go with the steel moment frame or the cantilevered column. So here's the question I get all the time. Every owner comes to me and says, give me a price. How much does it cost? I get this question all the time. And my answer is, it depends. Okay, I can't give you a cost. We first have to do some sort of analysis. We have to do a step one. And I emphasize that because, again, my role in this process is as an engineer. I'm not a contractor. I mean, I am a licensed contractor, but I don't practice construction. My job is as an engineer is to evaluate the building and give you your best option. Then you can go and get the contractor of your choice, or I can recommend somebody to you who can give you the price. There are two ways that you can proceed. The first way is what's called the DesignBidBuild process. This is the traditional way. In the traditional way, step one, we do a preliminary evaluation. Does your building comply? Maybe your building already complies. Just because they gave you the notice, it doesn't mean that you necessarily have to do something, because it just means that they're letting you know that you need to examine your building. Is it a soft story? We have to do some destructive testing. We have to come out to the building. We have to cut some stucco. We have to see whether or not the columns are steel or they wood. So we have to do some evaluation unless we have a set of drawings. Then we have to do some calculations. We have to see, going back to the 5 options, which one of the 5 options is going to work? Is there a 6th and a 7th option? So we have to do some engineering. We have to evaluate. Then, after we do the evaluation, you can come up with a cost. And then you can develop your tenant habitability plan, pull your permit, which we will help you with. And at this point is where you retain your contractor and start with steps 6, 7, and 8, which is to engage the contractor and let the contractor go do what they do, which is to build it. This is the preferable option. This is what I recommend, option number 1. Option number 2, another choice. Some people don't want to take the steps of doing the evaluation, the structural design. Some people want a price, and they want it done now. So there are some companies, we call them design-build companies. This is called the design-build process. The design-build process, they will do some sort of preliminary evaluation, but now what happens is the contractor steps in at the very beginning, and the contractor will bring in an engineer to prepare a design. So the initial steps of evaluation and looking at options is eliminated for the most part, and the design builder, the contractor, will then just come to you with one option, with one price, and say, that's our price, that's our solution. And they will go straight to design documents. It's definitely a faster procedure, but my advice to you as owners and tenants is that you are then disengaged from the different choices. And sometimes this will work. I'm not saying it's not a bad option. We've done it. We work with contractors, but I just want you to be aware of the 2 choices, because there are a lot of people that are running around in town who are offering only the 2nd option. I want you to know that there is a 1st option. And I would highly recommend, especially for those of you that have more than 20 units, get a construction manager. Don't try to do this yourself.